The next example is warehouse location or in general location problem. Now this is the last example we're going to see in this chapter, so we're not going to cover the rest of the chapter. So here we have 4 customer locations, okay, and they have a certain demand per year, and these customers are located in these coordinates in an XY plane. Okay. Now we want to locate a warehouse in such a way that the distance and the shipments made, the sum product of the two, is minimum. So that way the total load or shipment load will be minimized. So where do you locate that warehouse in such a way that we can reach the customers very quickly? Okay. And we can use this method to not only locate warehouses, you can use clinics and hospitals and factories and banks and courthouses. So there are lots of different applications for this. Now, there are 2 ways in which you can compute distances. One is as the crow flies, which will be like a straight line distance from one point to the next. Or we can do rectangular distances. That is, like in, suppose if the geographical area is a city, downtown area or something like that, where it is not possible to travel in a straight line way. So you can only travel in perpendicular fashion. So in such a situation, using straight line distance will not be appropriate. But on the other hand, if you have large geographical area, the entire country or an entire region of a country, then instead of, if you go rectangular distance, that will not be very appropriate. So you will be able to go from point A to point B more or less in a straight line fashion. So straight line computations are appropriate. So let's look at the example in both ways. Okay. So here we have the customer data already given. So the customer coordinates are given here. So that's the first thing we need to get. And then we have the annual shipment. So this is the load placed on the warehouse by each of the demand locations. Now we want X coordinate and Y coordinate of the warehouse where we want to locate it, and that's our changing cell. Okay, so let's give a name X coordinate and Y coordinate here. Okay, first let's look at rectangular distance. So the rectangular distance will be, you go the difference between the x-axis values, x coordinate of the customer, x coordinate of the warehouse. Okay, so that will be the distance, horizontal distance. And then you look at the difference in the y coordinates, so that will be the vertical distance. Add the two, so that will be the rectangular distance for that customer. So if you go like absolute value of the x coordinate minus x coordinate of the customer minus the x coordinate of the location, so that will give you the horizontal distance, plus you do another absolute value of the y coordinate of the customer minus y coordinate of the warehouse, and that will give us the rectangular distance for customer 1 to the warehouse. Now, okay, so that will give us the distance. So let's give a name for this, vertical distance. So let's call it vertical distance. So total annual distance then is a sum product of that with the annual shipments. So how many units are shipped times the distance, and this is what we have to minimize. Let's give a name. Okay, so let's run solver. solver, we want total annual distance to be minimized. So we have to find the x coordinate and the y coordinate. And there are no constraints here. We have to go and make sure that use multi-start and require bounds variables are removed. And you solve. Okay. Then we can format it. And here we have selected the location of customer 2 as our location for the warehouse. Now what if we want straight line distance? So this is our vertical distance, and we used vertical distance to find the total annual distance. So we want straight line distance. So let's look at straight line distance. Okay. Now this is the formula for straight line distance. So you take the difference in the x coordinates and square that, difference in the y coordinates and square that, and add the two squares and take a square root of that. Okay. That will give us the distance between 2 points as a straight line. Okay, so we need to set that up, and in Excel there is a function that makes this job easy, and here is that function. So you have sum x m y2, so that is, it will take the x value from the first range and the y value from the second range. So x m y, x minus y, so two ranges, and then square that. Okay. So let's do that. So that will be sum, okay, x m y 2, right? Okay, so we have the x and y coordinates of the customer, comma, the x and y coordinates of the warehouse location. So you'll take the first value here, that minus that, square that, and then take that minus that, square that, add the two. Okay, so that will give you that part. Now we have to take a square root, so we need to include that. So go back here, do a square root, and end that with the square root. So that is the straight line distance. Okay, so now let's give a name for this straight line distance, and do a sum product of the straight line distance with the annual shipments, and use that as our objective function. If we did that, okay, that will give us a different answer, of course. Okay, let's give a name here. Straight line annual distance. Okay, so now we use solver, change that to that one, and the rest are the same. So we have multi-start checked, so solve. So now we get a different location, very close to the customer 2 location, but it's slightly off.